The cloud provides three major workload services available to you as an administrator. We talk about IaaS, or Infrastructure as a Service, PaaS, Platform as a Service, and SaaS, Software as a Service. We're going to focus in on that first one, IaaS, Infrastructure as a Service, providing you that traditional virtual machine environment that you've been using maybe on premises for many years. My name is Bob Tickelman. I'm excited to be your guide for this module on Azure Virtual Machines. We want to take a broad, high-level look at what virtual machines look like inside of Azure. We've got other modules that we're going to cover and dive deeper into some of the concepts I'm going to introduce today that will provide a capability that would be hard for you to be able to replicate in your existing VM environments, whether they're using Hyper-V, our product, or things like VMware are the two major products that people are deploying extensively internally in their on-premises data centers. We are going to be able to far exceed those capabilities using Azure Virtual Machines. We'll take a look at sizing, opportunities from regions and deployments, as well as different types of scaling. So let's get into this. When we take a look at those three major services, as I said, in the on-premises world, you're responsible for everything. You have to take care of everything from the building itself, power, physical infrastructure, and then everything from installing operating systems, network controls. You can just see the full range of capabilities that you have to provide. When you look at the left-hand side of those columns, those are the three values that we take a look at from a cloud perspective, IaaS, PaaS, and SaaS, where we have what's called a shared responsibility. And so we're going to be focusing on the IaaS right now to take a look at where Microsoft is going to take on the responsibility of a lot of that physical infrastructure. We've shown you in other modules that we have over 67 regions, and this is not just one data center. Go watch some of those other recordings, and you'll see the massive amount of infrastructure and resources that are available. And I'm going to say that there's few organizations on the planet that can do what we do at the scale that we do from a performance, high availability, so it would be hard for you to compete against what we can do at that level. We'll take on that responsibility. Now, what we're going to provide for you is that platform for you now to deploy your virtual machines. I had this opportunity of working with a customer that had 6,000 applications that ran across 27,000 virtual machines deployed globally for them, those applications. We were able to come in and remove those virtual machines and be able to now go to Azure and deploy them inside of the cloud. And so 4,000 of those applications could move to Platform as a Service, where they no longer needed to have virtual machines at all. So that got rid of Windows licenses, for 19,000 VMs. They had got rid of 19,000 VMware licenses that they didn't have to pay for. And it meant that there was 19,000 servers that they didn't have to patch on a monthly basis. So that's Platform as a Service, and we'll do that in another module. But still, there was over 2,000 applications that ran across about 8,000 virtual machines that still needed to be moved to an IaaS infrastructure. And by taking that away, they didn't have to buy hardware anymore. A lot of the patching still was their responsibility, but the infrastructure itself became ours in an operational cost as opposed to a capital expenditure. So that's the beauty of an IaaS infrastructure. And me personally, I think that the Platform as a Service, where they move most of their applications to, and their goal eventually was to move off of the IaaS infrastructures and get those remaining applications into Platform as a Service, where I think the real value is going to come for your organization. So there is a recording on this if you want to go see that one later, but right now we're going to take a look at that traditional hardware infrastructure. When you take a look at the planning for your virtual machines, we've shown you that this is a global capability. It's available in all of our data centers around the world. We have VMs that range from as little as 1 VM core and a half a gig of memory up to over 700 cores and 12 terabytes of RAM. So that expands from virtual machine capabilities. It would be hard for you to even think of trying to build a VM that was that big. Now, the nice thing as well is you don't have to buy it based around what you think you need. You're going to be able to allocate resources based around what your expectations are. And if you've over-provisioned, you can just re-provision it down or up to meet your requirements. Now, I'm going to be using the term later in the recording of you can scale up or scale down. That's one of the benefits you're working with. Now, be a bit careful. If you scale up or down, it will cause the VM to go through a reboot cycle. So make sure, especially if it's a production workload, you're not just randomly scaling things up and down, because it will cause that VM to shut down, lose access for a bit, and then come back up. But it is a global service, massive capacity that you're working for, that you're paying for only what you use when you use it. So if you've got lab environments that you've got that you only need for small periods of time, you don't have to provision them in the physical world in the VMs that you're building. You can actually just spin them up and then shut them down as needed. When you take a look at the virtual machines, and I'll be doing this in an example in a bit, so I'm not going to spend a lot of time on the slide, but as I said, we've got VMs that range from 1 core and a half gig all the way to these massive compute nodes that we have. They've got GPUs, and we break them into several categories, and I'll call that out as we take a look at the graphical interface. We're getting into it, but know that not all services are available in all regions, and I'll demonstrate that in the graphical interface, where if I go to US East, which is our biggest region, our favorite region, gets everything first, has something like 1,000 different SKUs that they're working with, where other ones might only have 500 or 600. So know that not all resources are going to be available in all regions. When you take a look at the structure of a virtual machine, you only pay for what you use. And so if you deallocate or you turn off a virtual machine, you're not paying for the compute, memory, and network capacity, but you will be paying for storage. Now, I want to take a look at the virtual machine itself. Hopefully you're all familiar with this. When you have a virtual machine, it is made up of compute, memory, storage, and networking. Those are the 4 main resource allocations that are going to be allocated to the virtual machine, and you'll see this as we provision them. But specifically when regarding storage, that C drive that is mapped, if you go into File Explorer, is actually marked as or mapped to a thing called a VHD or a VHDX. There is a file that lives someplace that might have, it's Bob's C drive. So that file lives in storage someplace that gets mounted with the virtual machine. And so it's going to live in storage, and this is why you want to take a look at our storage modules and all of the attributes that we talk about in there, that all data is going to be stored 3 times. So if you have a VHD that's associated with this virtual machine, it's going to be using Azure Storage. And so all the things that we talk about in Azure Storage, if you haven't gone and seen those modules, make sure you do. Now, one of the things that happens on your C drive, you may or may not be aware of it, is a thing called a page file, which is usually 1.5 times the amount of RAM that you allocate to the virtual machine. So if you have 64 gigabytes of RAM, you're going to have 1.5 times that amount, so a little over 96 gigs of storage just to handle the page file. Now remember, you're paying for storage and you're only paying for what you use. Well, you're now paying for 96 gigs. That's just a page file. One of the things that Microsoft does, and you'll see this when we pick the virtual machines when we deploy them, is a thing called an ephemeral drive. And in this case, you can pick a virtual machine, and most of them do have an ephemeral drive that comes along with them. So when you build a VM, and that's what I'm going to do in the example, it will build a C drive. When I go in and show it to you, there's going to be a C and a D drive. Now that D drive is a temporary disk, and I can't stress this enough. I've had a number of customers, and there's a file that says, do not put files here. And so they delete those files, put some files on, and they reboot the machine, and it's still there. They're going, wow, it looks like it's not there. Well, maybe things changed. And they start putting files there, and eventually I get a call from them going, hey, Bob, what happened to my files? And I said, well, where were they? Well, they're on drive D. Don't use drive D in an ephemeral-based drive system, okay? It is there for the system, and it is unreliable in its ability to restore or keep files in there. It's there for the system's use. So that way, if you ever deprovision or turn off that virtual machine, that drive doesn't allocate towards the storage requirements, because even if you turn off a VM, yes, you're not going to pay for compute. Yes, you're not going to pay for memory. Yes, you're not paying for networking, but you will still be paying And it's not a lot, but you'll still be paying for the storage of the VM that's even turned off. So now you can also build additional drives and attach them to your virtual machines. Now, I'll be talking about backup in another recording, and it's amazing how many people are starting to take a look at IAC, or infrastructure as a code. And so you can deploy virtual machines. We did a whole module on how to deploy virtual machines using templates and PowerShell and CLI. You can deploy a virtual machine much, much faster than you potentially can from recovery. Now, I'm not saying don't back up, because remember, backups are still needed, especially for your data, but you may want to redeploy the virtual machine and then have your drives, if the drives weren't affected, just being able to attach to it. Not really part of the course, just want to introduce it into you, for you, but you can have these drives and build the virtual machines very, very quickly as a way to understand the structure of how all of them come together. I can build my C drive using HDDs, or standard hard drives, for performance and cost, and then I can have things called ultra disks that might get me upwards of 160,000 IOPS from a performance. So that's where I'm going to put my SQL and my tempDBs and my log files on those drives, separate from the operating system drives. So take a look at best practices. We've got a number of them documented that you may want to take a look at. Whenever we take a look at virtual machines, we take a look at administration of those virtual machines. I would encourage people that are connecting directly to the virtual machines, or even logging onto those virtual machines, as probably not a best practice to work with. There's all sorts of potential dangers that happen by you either connecting to or physically logging on to the machine by RDPing to it, or the remote desktop protocol. You'll see that on port 3389, and port 22 is used for SSH if you're a Linux person. RDP requires ports to be open, and depending on where those virtual machines, we've talked about a hub and spoke network in a previous recording. So I might have some hub network as my VNet that is connected to multiple spoke networks, spoke 1, spoke 2. Now you can have multiple subnets in each of these, if you remember on the networking modules. What you have is a very special one that you can deploy in a hub network that we're going to call the Bastion network. As opposed to having to have a person who's looking at these VMs using RDP to connect to all the servers in all these different subnets to manage them, what Microsoft provides, because then you would have to provide some public access to this, Microsoft provides the capability of having a Bastion network and a set of Bastion servers. That's what they're showing you here. I can now connect to the Bastion network, so I have a VNet for that. That now allows me to connect to all of the connected. If you remember from the networking module, we talked about VNet peering. I can now hop onto the Bastion network. Some of you might have used terms like jump boxes for this. You're going to connect to the Bastion network and then use that Bastion connection to be able to connect to all of the servers in all of the connected subnets throughout the VNet structures of your hub and spoke network that you're working with. So it's a great way to build a secure connection. So you're coming over, in this case, 443, so you can just use an internet protocol. I can connect to the Bastion environment and then use these local protocols to connect to those devices. Now, what you may want to do is actually install tools that are on the Bastion and not RDPing directly to the machine, but then use those tools to make the connections to actually administer those VMs would be the recommended method. But if you needed to actually remotely connect to that desktop in that backend pool, possibly, you could do it with the Bastion would be the recommended method. So let's go in and take a look at the creation of a virtual machine and some of these connection features. So let's take a couple of minutes and look at some of the characteristics around virtual machines. I'm going to walk you through the start of a build, and then I've got one already built that we'll take a look at, and we'll show you how to use Azure Bastion to connect to it. As with most things in the graphical interface, things change on a regular basis, so what you might be seeing might be slightly different, and this is where we often recommend using things like templates or command line tools. You need to have resource groups and subscriptions. Your virtual machine names don't have to have a specific naming convention. Microsoft does have a recommended one that you may want to use. And we have our different regions that we're working with. I'm going to go to US East just to show you some of the differences. As I said, it is our favorite region and our largest region, so it gets everything first. So it's the best one to do a comparison. We have different ways in which you're going to deploy your virtual machines, and these are going to come up in other recordings. So I'm not going to go into them now, but things like availability zones, availability sets, and scale sets will be covered in another module. I want to come in and take a look at the different images. Now, these are baseline images that are provided by Microsoft and have all of the currently supported versions by a number of major vendors of operating systems. So all the Windows operating systems and a variety of Linux distros. Now, it doesn't mean that you can't use other ones or unsupported versions. I've got customers that we're still working with, believe it or not, Windows Server 2003. Now, we've worked off of that, but we could actually create our own image disk and use that to deploy as part of a virtual machine set. So just because it's not in there doesn't mean it's not available. You would just have to look at the sessions or do your research on how to create your own image disk. Now, I do want to take a look at these sizes, and this gets into that component I was telling you about. Everything from as little as a half a gig of memory up to a core, up to 700 cores and terabytes of RAM. Now, you can see there's over 1,000 different SKUs that are available for me here. Now, this is going to take a while to load up. I'm not going to spend all the time, but 1,000 different SKUs that we can work with. It's going to ask for some basic information about the username and passwords that's going to be needed to connect to it. Do I need inbound ports to be opened? And this is those RDP ports that we were taking a look at. And do I need to have licenses? What's going to happen from a disk perspective? So we've got our operating system disks. How big do I want that disk to be? And what kind of disk do I want it to support? Premium SSDs, standard SSDs, I can use HDDs. They have different performance and cost values. Not huge differences, but you may want to take a look what some of those are going to be. And this is where I could add those additional drives. Now, the image that I've picked is an ephemeral system, and so it's going to have a drive C and a drive D, and so any additional drives would get drive letters above that. Taking a look at networking components, what virtual network do I want to project this into? I don't have to, but I could already put it into a VNet and a subnet specifically. Do I need to give it a public IP address? Again, probably not a good idea to make them publicly available, but you can if you want. Do I need load balancers? And these are going to come up in other systems when we take a look at availability sets and scale sets, because maybe you're going to have a group of virtual machines working together. So I can either create it at this time, have them pre-built, or build afterwards and add them to the back-end pool that we talked about when we discussed load balancers. Under the management piece, I can get into several management components. There's an auto shutdown feature, but there's not an auto startup. I typically don't use this one, but you have an automation service inside of Azure that can actually schedule startup and shutdown of the VM. So I tend to use that one, but it prevents from people starting VMs and forgetting about them and leaving them running maybe over long weekends when they didn't need to be running and incurring the cost. But there's all sorts of automation that we can work with. We can integrate this with our Entra IDs. So instead of having me create a user account and password locally, we can now have this have accounts coming from our Entra location. We get a series of monitoring. Now, the resource of the virtual machine is going to be monitored by Azure, and it's going to make that information available to the Azure Monitor service, which we'll be covering in another module. What I need, though, is I know that the virtual machine was 85% CPU utilization. That's what Azure Monitor sees, but it doesn't see inside of the virtual machine. If you take a look at Task Manager in the VM, you will see the discrete processes and threads that are taking up that resource allocation. If you need that information, you have to get those logs and metrics emitted from the virtual machine and made available to Azure Monitor. And so there's several different ways to get that information available to a broader monitoring solution you're working with. I'm not going to get into all the tabs, but that is some of the stepping that you can go through in the creating the virtual machine. I am going to go back just to do that one comparison I told you I would do. So from Canada Central, let's take a look at the different SKUs that we have available. And if you remember, there was, almost 1,100 that were available. Now, Canada Central is fairly large. It's got, 1,000 of them, these different SKUs. You can see it's got the number of cores, the amount of RAM that it's allocated, how many data disks that you're working with, what are the IOPS that you're working with, all of these values. And instead, I can get up to some that are quite high end. 64 cores, 128 gigs of RAM. I'm not going to go through all of them, but you can see that we have these different options. Now, I'm going to go into a virtual machine that I already have created, and we'll take a look at some of the options. I've got a virtual machine called Standalone here, and you're seeing all these different characteristics. What region is it built in? This one does have a public IP address. If I needed to, I could connect to it. It's running Windows Server 2025. I can come in and change the size if I wanted. So currently, I see what size, and this is that scale up versus scale back down. It's currently running on 2 cores with 8 gigs of memory. I could now scale that up or down, but remember, it would cause the system to reboot. I've got security features, backup features. There's some system settings. A number of these features can be adjusted over time. But what I want to do is take a look at this feature called availability. This has changed over a period of time. There was a point when we used to teach that if you create a virtual machine, you could not add it to an availability set, an availability zone, or a scale set after the fact. Things have evolved over time, so what used to be true may not be true today, and some of them have changed. So I'm not going to get deep into this, but you see that it talks about availability zones. You could potentially, it doesn't actually move it in, it does a copy of it. So I'm not going to go through all the details, but I have some limited capability of taking an existing virtual machine and potentially adding it after the fact into an existing availability zone, scale sets, and you'll see availability sets. There still is no availability to do that. So just want to kind of touch on that. It's not really covered very deeply in the books itself. Now, what I do want to show you is that Azure Bastion service. I could connect to this device using that publicly available IP address, that 20 dot, and I would connect to it. But now I've exposed maybe a service that's on the back end, and this machine is in the data tier back end of a peered subnet, if you remember or saw the recording on networking. So I could take a look at the networking services. It will show me what VNet and what subnet I'm in. And so you'll see that I've got firewalls, and it's from the Spoke 1. And we talked about there was a data tier, an application tier, and a web tier. And so it's actually in a Spoke network from even the hub that I would have to then make publicly available. I'm going to be able to do this through Azure Bastion. I've deployed the services, and I'm going to be able to connect to it. I'm just going to actually already done that. And so here I'm connected to the standalone computer. You'll see that in just a second. Come into Server Manager. So the server name is standalone, and I would manage this just like I would any other server. You'll see how many cores it has. So I've got my 8 gigs of memory, and I've got my 2 cores. So that's what I provisioned for it. So there's the ability to connect through Bastion. And if I wanted to, I could actually still connect using a traditional method using RDP, getting the information. So I've got an IP address from a public location, but not the recommended method to be able to do this. Okay, let's go back to the lecture. So we saw the actual building of the virtual machine. I want to do just a quick whiteboarding session so you can understand the underlying infrastructure, because you need that now so that you have a better understanding in other modules where we get into availability sets and scale sets and availability zones. So just bear with me while I give you a bit more information before we close out. I'm going to start this conversation now, and I'll pick it up in another module. But if you remember, we have that ARM layer. And the ARM layer is how you come through into Azure, and then there's the resource providers. And those resource providers are the compute resource provider, the memory resource provider, the networking provider, and the storage provider. So if you have a virtual machine that you want to build that has 4 cores, and it has 16 gigs of memory and networking, you would come through the ARM layer and you would connect to these different resource providers. Now, in another module, we talked about an Azure region, and so I'm going to take a look at a standalone virtual machine. I'm going to introduce, or if you remember from the module where I actually talked about them, we talked about things called fault domains and scale units. So as we deploy these resources, that virtual machine will find a node someplace inside of this region, whatever region is, inside of a data center, and it will build the virtual machine from a memory, compute, and networking component. So those resource providers would be associated with that node. Now remember, we talked about storage is the VHD. There is a file someplace that represents the VHDs that make up the C drives, the D drives, the E drives that you're working with. And if you remember from Azure Storage, all storage is stored a minimum of 3 times. And so that file that represents the VHD that is associated with it is stored a minimum of 3 times. This is the C drive. Now, I want you to imagine what would happen if this node failed. You would lose access to that VHD. What do you think would happen to your virtual machine? Would it stop? Would it continue to run? Would it magically reboot? In this case, it would continue to run because I still have 2 other copies of the VHD that are providing that base operating system to that system. What do you think would happen if this node failed? Would your virtual machine stop? Would it continue to run, or would it magically reappear? In what is called an unexpected failure, this becomes what's referred to as a self-healing virtual machine. You don't have to do anything. Microsoft is monitoring this entire surface. We know that a virtual machine that, for no fault of your own, has failed because of underlying infrastructure. What will happen is we will know that that virtual machine is no longer there, and we will find another node to deploy that virtual machine to, and then we will have the HDDs that are needed to make it running. So it is self-healing. It may disappear for anywhere from as little as 30 seconds to 2 minutes, but all of a sudden it's gone and then it comes back. It is self-healing. Well, what would happen if the entire fault domain went down? Would it stop? Would it keep running? Would it magically reappear? In this case, it would just stop and be gone. So guess what we do? We don't do what I just drew. Very similarly, if you take in the concept of the fault domains, I am still going to have to put my VM, the actual virtual machine, for its compute, memory, and network, have to be associated with a node. We then take the 3 copies of the VHD and we put it across 3 fault domains. So this way, if that node were to fail, or the entire fault domain were to fail, we still have potential copies that we could now self-heal and have that VM reappear. Now that's just what happens with one. What happens if the entire data center goes down? These become other options that are my prelude to why you might want to watch another module from me, where we're going to take a look at high availability. So with that bit of a teaser, you now understand the basics of virtual machines inside of Azure. You see the benefits of IaaS, or infrastructure as a service, where Microsoft takes on the responsibility, and as I just demonstrated, a significant amount of high availability and management of the physical infrastructure, the security of the services. You know, even our CEO just can't walk up to a data center and say, hey, I'm the CEO of this company, let me in. There's a whole strict process. I've been to them, I've seen our tours. There's actually a data center tour that you can do virtually online. If you want to do a Bing or Google search for Microsoft Azure Data Center Tours virtual, you should be able to see it. It's got that globe that I've used in other recordings, but take a look at the data centers and seeing that infrastructure that you're going to then deploy your virtual machines around. We provide a wide range of virtual machines that you can now scale up and scale down depending on what your needs are, without it saying, gosh, I either over-provisioned or under-provisioned and I have to wait for a budget allocation to then repurpose that hardware. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.